Hello everyone, I'm Gaganveer Singh, and in this video, I'm going to demonstrate how I created a graphical user interface that allows users to blink their name in Morse code using an LED on Raspberry Pi for my task 5.3D of SIT210 embedded system development. To complete this task, I made use of GTinter library, which facilitates easy GUI development and works on Python. Moving on, let's understand the hardware components and the circuit layout and see how each component connects. In this system, I made use of Raspberry Pi 4 Model P, an LED, a resistor, breadboard and some jumper wires. As you can see from the circuit diagram, the longer leg of the LED is connected to the GPIO pin 14 through a resistor, and the shorter leg, known as cathode, is connected to the ground pin of the Raspberry Pi. When GPIO pin 14 goes high, our LED will light up, and when it's low, it will turn off. By controlling this high and low signals with specific timings, we will represent Morse code to the LED blinks. Now, let's understand how the program will work by going through the code. Firstly, I import the essential libraries. The time library is used to manage the LED's blinking rate. The GTinter library provides the GUI elements, and the GPIO0 library allows for interaction with Raspberry Pi's GPIO pins. Here, I define the hardware component, initializing the LED, which is connected to GPIO pin 14. In this section, I have set up the appearance and dimensions of the GUI window. The title of the application is Blink Morse Code, and I have chosen specific fonts for both regular text and the title. These are the variables for Morse code timing definitions. Dot is the basic unit of time, a brief blink. A dash is a longer blink, 3 times the duration of a dot. Space between symbols is the pause between individual dots and dashes within a letter, equivalent to a dot duration. Wait between letters is the pause between individual letters, which is thrice the dot duration. Wait between words is the longer pause between words, 7 times the dot duration. Here, I have set up a Morse code dictionary where alphabets correspond to combinations of dots represented as 0 and dashes represented as 1s. This is going to be used for mapping to blink the LED. In the blink dot function, the LED illuminates for the duration of dot and then switches off. Similarly, blink dash, the LED remains lit for a dash duration. After each function executions, there is a pause to clearly differentiate signals. The blink letter function translates individual letters to Morse code. It displays the current letter being blinked on the GUI. If the letter is a space, the function waits for a word separation duration. If the letter isn't in the Morse dictionary, it is skipped. For valid Morse characters, the function iterates over its Morse code representation. For each 0, it blinks a dot. For each 1, it blinks a dash. The blink name function starts by retrieving the user input and validating the name's length. It also checks if it is not empty. Then it loops through each character of the name. If it is a valid Morse character or a space, blink letter is called for that character. After each letter Morse code is blinked, there is a waiting period to separate it from the next letter's code. Once the name has been fully blinked in Morse code, feedback is provided to the user through the GUI. Coming to the GUI components, I have integrated several widgets into the application. The title label displays the application's name, Morse code blinker at the top. The prompt label, positioned right below the title, provides with clear instructions asking them to input their name. The text box, this is where user can type their name. The feedback labels, label 1 and label 2. These are dynamic labels which provide real-time feedback to the users. They will show which letter is currently blinked, the complete name being blinked, and other essential methods like errors or completion notifications. The start button. Once the user inputs their name, they can initiate the Morse code blinking by pressing this button. The exit button is to provide a graceful exit from the application. It not only closes the GUI but ensures that Raspberry Pi GPIO pins are appropriately reset. Now, let's have a look at the demonstration video and see how is it working. As you can see, entering a name longer than 12 characters is not accepted, and a message name should be less than 12 characters is printed. And also, if the name is empty, the message name cannot be empty is printed. But the name is in the given range and is not empty, the name starts to blink, displaying which letter is getting blinked. And after completing the blinking, we can see the message finished blinking.